Very happy to have you here, Mizo. I know that you're active in several cities and done several things, so looking very much forward to get your presentation now. So the floor is yours. Warmly welcome.
Thank you. So I will share my screen and then I will shut down my camera so you can get better experience. So, can you see my screen?
Yes, that is working.
Okay, great. Yeah, so my name is Mizo. I'm from Complete 3D. We are one Swedish company that have worked, have combined experience for more about 25 years of 3D modeling, visualization, game development, and photogrammetry. See, it's working. Okay. So now, who we are, what we do, and about Smart Visuals. It's what I'm going to present today. Uh, we are a specialist in development of 3D solutions. We have worked for many years in this field and combined together different knowledge from different fields, and we have built one platform for visualization and the integration of data, but also we are producing 3D data, and we are also working in other fields that I'm going to show in this presentation. Okay, if it is for me. You can just stop me if you have any question or something, so I can explain. Uh, so what we do, we produce in 3D data, usually 3D city models, but also different type of data, 3D assets, 3D for 3D visualization, and we are also doing consulting about 3D and training in different softwares for photogrammetry, for example, GIS, 3D modeling, 3D visualization, and Smart Visualizer platform that we have developed for 3D visualization and 3D data management, usually in city planning, but also in different types of projects that need 3D for 3D data for visualization and work with 3D data. Production of 3D models. In this case, we have developed our own algorithms that we using, and we can produce different type of 3D models from in different applications. Photogrammetric 3D city model, usually they are produced manually. We have special 3D monitors and then photogrammetric software, and then we are mapping roofs and mapping details in the images, and then in that case we are producing 3D city models, everything from buildings to different other roads and so on, other details in the city. So we can produce entire 3D city model by using this method. Photorealistic mesh models. Here's also possibility to automatically produce mesh models, usually using photogrammetry, drone images, or other type of images, even mobile mapped images. So we can put everything together and then create 3D city models or 3D models of industry or outdoor, indoor, and so on. In this case, it's a church. Produced with using 3D drone models and photogrammetric software, and an automatic method for producing photorealistic photogrammetric 3D models. We have also developed algorithm for producing 3D models from point cloud. In this case, it's LiDAR data. We have this type of data for entire Sweden, and then we can use this data and produce 3D city model in different level of details. In this case, LOD2. This data for entire Sweden is not quite high resolutions. It's 1 point per square meter. So, but it's enough to get all roofs possible up to large, from small villas to large industries or churches and so on. So we can see roof shapes and tree shapes in this type of data, and then recreate those as objects and geometries. We are doing also 3D city model texturing. In this case, it's used mobile mapping data from Street View, but there is also possibility to use oblique images from airplanes that can be textured on the walls by using automatic methods. And there is also possibility to use tree and vegetation, or to use point cloud to extract tree and vegetation from point cloud and then recreate those in the scene in 3D visualization. In this case, we can find every single tree and height of the tree crown, and then even we're using a different type of data. It's possible to separate what is the type of tree or the type of vegetation, and then to recreate as a 3D object for visualization. As in this case, we are visualizing 3D trees as a 3D models. But also, 3D data processing, any type of data. It can be 3D city models. It can be also BIM models in EFC file format that we have helped many customers to recreate data, or to convert data, or to make data more reliable, or to be able to use in different applications, different softwares, and then to convert to different formats, or even to put data in the coordinate system if they are missing the coordinate system, or they are not right scale and so on. So we can make those to our customers and create those process data to them. We are also working with consulting. I have helped many municipalities in Sweden and developed their 3D operational units. In this case, we are building their data gathering operations with different instruments and methods. We are building 3D 2D databases to them, how to store data, how to work with data and gathering. Then we are educating them in different softwares and in different solutions, creating automatization for in this digitalization process, and then implementing different technical solutions in this operational pattern. So we are working very close to our customers so that they are able to have one flow and one sustainable data flow and data management. And usually in municipalities, they are in need for 3D city models, and then they are also in need to be able to produce data by themselves, and then also to manage data and host data by themselves for in different applications. We are usually talking about digital twins, but for digital twins, we need great data. We need data as the default underground underlying data for the different application of the digital twins and smart cities, and then to application of other data information for as IoT information and so. Yeah, in this case, by consulting and helping those type of customers, we are developing and using doing different type of development and also training in different softwares for automation. For example, EFIMI, feature manipulation engine, Blender, Metashape, ESPA, photogrammetric 3D mode, photogrammetric softwares, and then we are also doing training in those softwares. As I mentioned, we have also developed Smart Visualizer. It's a 3D web-based visualization platform. It enables project management and collaboration with stakeholders across various industries and different stakeholders. It can combine, import different 2D and 3D data from multiple sources, and then user can perform analyze and measurements using different tools, and then even allow us for editing and updating 3D models. So they can have their 3D models inside the platform, and then do updating of 3D models in daily basis. So they don't need to have any other solution for updating model. They are doing those directly in the platform. The platform supports also exporting in various file formats and even coordinate systems. You can import from one file format coordinate system, convert, and then export it in other one coordinate system or file format. And then there is also option to publish all those projects both online or on mobile devices by supporting VR, augmented reality, and so on. Here is the picture that is explaining Smart Visualizer in the three different use cases or three different parts of platform. The first one is importing of data and work with importing of data and data connection or data conversion. It can be imported from different sources, for example, hardware from drone, LiDAR, terrestrial, or sensor data directly connected from IoT. It can be software that some architect is, for example, sitting and creating something in 3D model in some software and then exporting as a file format, or by connecting cloud solutions, cloud as our WMS, WFS databases, OpenStreetMap or Google Maps, and so on. Data can be imported in different types as vector, raster, 3D mesh, point cloud, beam, or other type of geodata. And then also we have today's possibility to import 65 different file formats. And also, as I said, possibility to import in different coordinate systems, so we can connect or reconnect data and different files, different coordinate system in the one file. And in this case, we have our own developed file that is streamed in the web and visualized through the same file format. So everything is converted and then visualized in the same. Usually when working with different data types, you need, for example, to have a viewer or editor for vector, raster, 3D mesh, point cloud. In this case, we are streaming everything together in the one file format in the same platform, and then just splitting those as different layers. There is AI in the background, machine learned process that we have developed that can recognize those different type formats and files, and then learn about how to optimize data and how to convert data to visualization. Because those are coming from different softwares and different solutions, so there is they are not always the same. So there is also need to be able to learn about those different types and formats, and to be able to visualize them and to convert. There is also working with data. In this case, it's as I said, web-based. You are inside the visualization, and then you are working with file data in the background. There is possible to visualize data with the different camera navigations, orbiting, land, flying around, looking around. And then it's also possible to create scenes for presentation and interactive presentation and 4D visualization. So you are able to visualize process, you're able to visualize different solution or different suggestion, for example, different data suggestions in decision-making process. Then we have also analyze, different tools for analyze, obstacle analyze, for example, in a city, or for 4G 5G masters in telecommunication. Dynamical high analyze to visualize different heights in the terrain, for example. Dynamical lights from different sources, can be shadows, it can be the sun, it can be also city lights. Then solar potential analyze, that is using diffuse from sun, and then can visualize different how diffuse is impacting on the, for example, roofs or walls. Cross section for visualization of complex 3D models, BIM 3D models. X-ray to visualize through the model and different layers, for example, underground installation or city tunnel or something like that. Flooding also to do analyze, and then also different measures for area, distance, slope, profile, volume, surface, and so on. All this data that is imported inside Smart Visualizer is editable, so it's possible to edit data and cooperate in real time. And then also it's possible to make data, create inside the platform. For example, volumes of the buildings or something like that. Something that you will need to be able to sketch and visualize as a suggestion. Then we have third part of the platform, and it is exporting data or publishing data. You can export those data that you put together inside visualization to third part. So it's able to combine data and export in other file formats or coordinate systems. So it's very easy. It's open data flow inside this, and the data is reusable, or yeah, you can import, export, and visualize in other softwares or other formats, and then re-import again in the Smart Visualizer. If you are, for example, exporting part of city model to SketchUp or Revit or something like that, working inside other software, and then just exporting back that you have created, not the entire 3D city model. So it's very easy to cooperate with other platforms through sharing of data. It's also possible to publish those projects, entire city or small projects, so for infrastructure, for example, or industry or something like that. It's possible to publish those through the web and then also visualize through the mobile apps. And right now we are working on mobile apps that have uh, also support for virtual reality and augmented reality. Here are some of those analysis tools: solar, water, obstacle, high analyze, and different dynamical high analyze and sections. For planning, as said, it's possible to import different 3D models from different softwares in different file formats. It's possible to connect VMS, WMS. There is also simple object library, as this white model on the image below. It's also possible to edit terrain and edit 3D city model in the background. And it's also going to be updated in the city database, so you can edit it permanently or just for purpose of this project. And then also export any 3D data from the scene. Measurements are also possible to do inside. And then we have a demo from a couple municipalities, but then I have also a movie that can show you. Let's see how I can get this one here. That can show also a little bit about this I have already spoken. So yeah, it's a little bit speed up, so I will pause and play and then explain during the movie. As I said, yeah, it's web-based. It's quick to learn also. It's developed together with the municipalities and the users. And then it's also developed from the point of view of the user, how it's going to be to handle and used in daily works. For example, if you have communicator in the municipality, their tool, their main tool is Microsoft Word or something like that. So they are not familiar with 3D visualization and modeling and so on. So they are usually being thrown inside this, and yeah, you can create 3D scenes for visualization. In that manner, we have created platforms, so it's very easy to handle, very easy to use. It can be used, yeah, for urban development, survey, design. It's very easy to publish and share projects, and then to start public dialogue also. Here in Sweden, yeah, it's very common to involve citizens in democratic dialogue during this decision making. Yeah, here's example of creating new 3D model. It's just skissing a 3D model by drawing polygons, and then those polygons become volumes. So you can easy skiss and sketch and visualize. cut through 3D models, for example, if they are BIM models or some other 3D models that have more details. Editing background. As I said, different people of different different positions. They can be inside the same platform. GIS engineer or planning engineer, politician, that is a decision maker. Everybody are in the same platform, and they are doing work simultaneously. For example, GIS engineer is editing 3D models, background 3D models, in the while city planner is importing 3D data and creating 3D scenes for the detail planning and so on. Yeah, this is tide and flood analyze. You can visualize flooding in the city. Measurement with cross sections to visualize. So importing different type of data. In this case, it's the image on the ground, and then 3D city, and then 3D model from the architect that is imported in this urban design case. Then, as I said, communicators or city planners can create those information points about city and then describe and even get possibility for citizens to vote on or create comments about this project. Field of view or obstacle analyze, in this case for city modeling or city planning. So you can visualize how this new 3D or new building is going to make obstacle in the city room that is default right now. Making scenes that are switching camera, flying around, switching 3D models, switching content, and then also switching different analyze. Dynamical sun analyze that is showing shadows, solar potential by using diffuse from the sun is showing possible roofs or possible areas that can be used for implementing solar panels, and then visualizing shadows in different states of the sun. Here is also possible to create reports in the PDF that you can export and then get inside the map for this, for example, urban project, and then use use for decision making. Here is X-ray tool. It's possible to make X-ray or transparent layers, dynamical height analyze for visualizing different heights, and then also to connect other type of data. In this case, it's a WMS layer. It's map layer that you can see in Google Maps, for example, if you are getting if you wanted to show you streets or something like that. So it's different map layers that you can handle here in Smart Visualizer, and then choose which one will be visualized in and overlaid over the 3D map. And then also share and publish by exporting 3D model or exporting published model as a link or web-based published. We have also worked together with Sensitive and IGE platform, and then we've done some IoT integrations. In this case, we just took random sensors and then put those in the city. This was in quite early stages, 2020, I think, or something like that, 4 years ago. And then we just took some sensors and put those in the city, simulating different user cases, and then streaming IoT information in real time and visualizing values from those IoT integrations. Here is also one possible user case for smart city lights, for example. Usually, when they have broken city light, if they have a couple of those, they are going out and fixing the first one that get inside the system. But what if the third one, that is the lastly one broken, is making unsafe place in the city? Maybe there is also need to analyze and visualize which one should be repaired the first. and also other possibility to simulate and visualize by using IoT, using digital twin platform together with IoT integration, and then also be able to yeah, for example, dim the lights or get every other lights shut down to simulate and visualize how it look like in the real life also. Here is also one example by using real sensors and real position of those sensors in the yeah, working space of the sensitive office. Yeah, as I said, we are able to visualize sensor data, to stream sensor data or and values, but also here is possible use for connecting to real hardwares, real and then just remoting hardware, for example, lights or yeah, coffee machine or opening, closing doors and so on. So I have one more movie that is also I have mentioned about mobile platform. This is something that we have developed and are now out publishing. Uh, Visualization of all those different data types in the mobile, everything from point cloud, 3D models, 2D maps, and so on, can be visualized and streamed inside the mobile. Yeah, it's also, you can see it's a very quick visualization and data stream because we have this file format that is streaming everything in the same place and in the same stream. And then it can be possible by using that and to stream quite easy and quite quick 3D data. Yeah, here is some just possibilities for placing, standing and looking around from different, for example, urban projects. But it can be also used in any other different type, any project that can use the 3D data can be visualized in Smart Visualizer. So that doesn't need to be a large city model or something like that. It can be anything, just one 3D model modeled in SketchUp. In this case, this is augmented reality. I'm just choosing one building from the side because I'm not right now in the right municipality, so it's far away. It cannot visualize in the right coordinates. So I'm just picking one and then placing somewhere outside. And then in this case, it's BIM model imported in EFC file format, and then just visualized through the augmented reality through the camera on the mobile. So I can scale it by my own and then put on some flat surface, and then just visualize. If I am on the right coordinate or near the object that is going to be built, then it will show in real size and in real place. So I can go around or go through the 3D model. And in this case, we can visualize 3D city models, point clouds, and anything that is or can be in real place. So, for example, showing underground objects or showing something that is inside the other object, and so on. So, and then we have yeah, here is the 3D model of Ängelholm. Those are photogrammetrical models produced, yeah, semi-automatically, manually by using those special 3D glasses and photogrammetry, and then also textured with the oblique images. And in this case, trees are produced quite yeah, entirely automatically from point cloud, from laser data. And in this project, they have gathered all their detailed plan projects together and then create a scene for every project. So when pressing the button, scene will fly around and then switch 3D model that need to be visualized in this scene. So in this case, they can have endless data inside visualization that will switch and visualize different projects. And then also they are creating information for citizens that can read about and go to web page and read about different projects in the city. So here is the school that no, there is not, that I have visualized through augmented reality. Here is so and those are also in different file formats imported from different softwares inside this visualization. And they are also allowing citizens to be able to use different tools by themselves also. And then they have ability to discover and see all those models. They have also ability to, yeah, in this case it's disabled, but if they are enabling, it's enabled comments, for example, or yeah, voting and so on. I think we have some questions. Okay. So now we have also worked further with connecting IoT platforms, IGIO, with the Smart Visualizer. And so far we have done one new kind of configurator in the Smart Visualizer that is possible to list all sensors that are inside the IGIO. And then you can just pick one of couple sensors, enable those reposition if they don't have XY set, or yeah, if you need to position those manually, then you can choose which of those values you will display. So you can just pick those values, and then also you can change icon for this use case of sensor. Then it's also possible to gather different type of sensors in scenes, and then in that case you can get those together and be able to display in different type of sensors in the different scenes with different 3D model connections. Mm. Okej, Magnus, är det fråga till mig? Is it a question to me?
Magnus here. I'm not sure, but what I've seen looks great. But if you have all this type of information, if some deviations occur, for me, for fire rescue or rescue services or an alarm, that's a trigger for me. So if if an alarm goes and it triggers sending it to someone, this would be really interesting to have if to the first responder getting to the site.
Yes, yes. Yeah, I understand what you're asking. We don't have something like that today, but there is the possibility because we have built this platform as a platform that is scalable and open to any type of integration and user case. And in your case, I can directly see how it could be used. The operator can see everything in 3D. It can trigger alarm. They can also help to navigate, and then also by using augmented reality, the person that is on the field can lift up the phone and see through the reality, see where somewhere is the case for that utryckning. So yeah, there is quite possibility to do this, just to connect and then to use this type of data and this type of platform.
Thank you. That was my thoughts as well. So
yes.
Thank for a quick summary there. So thank you.
Yeah, thank you. Okej, det är några som lämnar. Så här har vi som sagt, sorry, here we have integrated EGO platform in the Smart Visualizer, and then in this case, as I said, we are just displaying every data that is inside the sensor, but then a user can also we are making a more search possibilities, so you can search the sensor types or sensor name or data field for different values and so on. So you can gather together different sensors, and you can visualize different sensor in different cases together with the 3D model. We have also done some other applications. For example, I don't have here, it's not published yet, but for example, just by drawing a path, you can get a bus or something like that car to drive to this spot. You can choose if it's going to drive back or it's going to loop, how fast it's going to drive, and so on. And this is very easy to applicate to the sensor in the real time. For example, if we have sensor in the bus or something, or fire truck, so we can visualize everything in the real time and then navigate in real time and use that type of data to visualize 3D model in the 3D scene.
Mizo, we have a question here for Klaus in the room here.
Yes.
But I can wait until the end of the presentation. Otherwise, I will
destroy
the flow. So I'll wait till afterwards.
Yeah, we get back to Klaus here.
Yeah. Okay. Now we'll see. I think I'm finished with presentation. Yes, I'm. So, yeah, that was that. That is that I was. That I needed to show you today.
Thank you very much, Mizo. Very interesting and very nice presentations. So thank you very much. Then we can get back to that actually to hear what the question he had. So Klaus, please.
Yes.
Okay, so I'm interested in the integration towards the IoT platform, and it's so it's not. You showed this example when you could control streetlights, but it's more like data in general. So like without controlling anything back. And I wonder how easy is it? And so, for example, from in sensitive, if all the data is formatted correctly and you have enough metadata, how easy is it to do this integration? And then the follow-up question, then it would be exactly as easier part to do it towards Things platform, for example, using the same API. Do you understand what I'm looking for?
I think so. I think I think I understand what you're looking for. Yes. Yeah, as I said, it's right now we have integrated with the sensitive with the EGO platform, and then we are just reading those information from their platform. But if there is both way, then it's also possible to remote hardware through the smart visualizer.
Was that answer enough, Klaus?
I'm not quite sure. So do you do an integration towards NGSI LD? Is that your integration, or is it like a deeper integration?
As I said, we have not done this type of integration. It's just the user case possibility that I have shown with those lights. But I'm willing to test those other type of integrations also, more deeply integrations. I think they are possible. Yeah, technology is here, so I don't see any obstacle to that.
Okay, thank you. Sorry for being so.
So there is an interesting, because that is also as Håkan did mention in his presentation, that it's vital that you can access the data at the data source and ensure that the data is done up to date. So that's why I think the Klaus question was also about how can we do such integration and get the real-time data from the IoT platform and the real data actually all the way from the sensor. And we are in the room here in this working group. We have in room here we have two other vendors of IoT platforms as well. So everyone here is of course interested in, okay, if you use a tool like Smart Visualizer and you want to cooperate like between two cities, but you have different IoT platforms, would it still be possible to use that platform? So that's why we ask about the possibility to integrate and how it's done. If it's, you can do an integration hands-on with very nitty-gritty, just getting into it, but or you can take a higher approach that is more general and can be applied.
Yes. Yeah. Yeah, that is the case why we are building this integration Smart Vision as a configurator. So you can connect anything through our API, for example, and then just connect the sensor, not from the platform, but directly connect sensor in the Smart Visualizer, and then just configure and then use as a source of data.
Yes, I'm personally a little bit afraid that people. What I see all around the world is people is often connecting one or two sensors just to show that they have IoT functionality. But as we have seen from the presentation of IoT platforms that we have done this year, we see that, and also from this presentation today, it's an extensive work to actually keep track of all the sensors in a good way. I mean, we have 10,000, 100,000 of millions of sensors in a city over time, and we need good tools to actually handle them. So I think we are many here that thinks that the good way forward is to actually make use of an IoT platform, but then propagate that data in a proper way into such an environment as you have been describing today. So,
yes, and it's much easier for in this case, for example, connecting different type of sensor to eGear. We are just getting one type of data inside Smart Visualizer.
yeah.
So it's much easier, much more safe also and secure to get data and to share data between.
Yeah, and also we actually in Jesper, I think he's with us on the meeting. He's leading an international work on standardizing how actually what units you're using for the measurement of different kind of data, and to unify that all over the world to make it easier to make sure that if you get the data from a certain kind of sensor, then you will know what the accuracy of that is and what data type it is, and to make sure that it also not disturbed and distorted on its ways to US and end users. So that is also an important work that we are engaged from the Swedish side.
Yes, yeah. It is very important. We have, for example, when importing 3D models, we have different units also for different scale and different measurement unit also. So it can be so they can be accurate, and then also by having different coordinate systems or all world's coordinate system, so we can get data inside the same place.
Yeah, maybe we can have a separate meeting and dig a little bit into the interoperability, because we have an interoperability in Jönköping where we try to connect two IoT platforms, but the interoperability, I think, between this kind of environment that you have described here and the IoT platform, as well as integration between your environment and also the operating system of in the municipalities, to make sure that what you do here is also usable for the daily work by cities. I think these questions are interesting. So, but maybe we can have a separate meeting to dig a little bit into that and understand more about what you do and what could be done. More people might be interested of that as well here on the meeting. Okay, let's see if we have any more questions now.
Yes, Anton.
Yeah, does my microphone work?
Yeah, it's working.
Great. So great progress of the S-Visualizer. It was really nice to see. Do you also now use the open Google 3D Maps API in your solution?
Not right now, but there is a plan to integrate that also. For there are not all customers that have 3D data or from different industries. Also, it's not just municipalities. They need default data in the background, but they don't have. So we are going to integrate Google Tiles also.
And are you using for the tiles that you're serving now? Is it Cesium you're using, or do you have your own solution?
It's our own tiles. All those 3D models that we have produced or that the user is sending to us, we are tiling up and creating our own quad 3 level of detail for streaming of data, and then converting to our format also.
Is it quad tiles or oct tiles? Do you also do on the height?
Quad tiles right now for 3D models, but oct tiles for point cloud. So and then we are now making one internal standard for octiles for everything, so that everything will be octiles because of BIM models and all those sensor data working around and working inside the buildings and so.
So a question to you, Anton, actually about this interoperability. Would you be interested also to participate in the discussion? Maybe we could have that as a team for in the working group. An upcoming meeting to actually discuss the interoperability, because it's of course not only interoperability from one 3D environment toward IoT platforms, but it's alike important for having the same interface or a common interface that can be used by several 3D visualization tools for connecting from the IoT platform side or an operating system. So the interoperability issue is a multi issue that. So do you have any thoughts about that right on the spot, Anton? Because I know you're also deep into the technical stuff on this kind of level.
Yeah, I mean, for sure, we would like to discuss. It would be really interesting. I mean, we're just trying to wrap our head around how things are going to work in the future, just as many else here is doing, and we have some ideas that we're happy to share around this with data spaces and how to treat the data. Personally, I don't think you should distinguish that much between GIS data and the sensor data and all that. Just treat it as everything as real-time information. So right now we're working a little bit with Stockholm City for their data portal. So I mean, they might be updating one area like Kista, for example. They have different areas for the city stored in a shapefile on their dataportalen.stockholm.se, and then they update that one every fifth year or something like that. So we use the publish subscribe kind of paradigm. So the same thing we do with the sensors. We can just subscribe to the Kista area, and whenever that value changes, the total square meters of Kista changes or something, that it will cause us an update, so you can have those kind of key performance indicators being calculated on data coming from different servers, different sources, and different types of data and so on. So, yeah.
Yeah, that's great.
I'm always eager to discuss.
Yeah, thank you. Yeah, interesting. So any more questions, thoughts, reflections? I mean, also have in mind now we have had a presentation, and I would like to see more of this kind of presentations, and maybe this will be the theme of the working group for the next year, if there is interest enough for that. And we also have to decide things like that. Then, okay, do we want the providers of the platforms to be the presenters, or do we also want the users of the platform to do their presentations? I mean, we have that kind of things we have to discuss, and that is also depending on if we can get hold of people that can make a presentation from the vendor side. I mean, some of the basic tools we're using are maybe American software with people very occupied, and it might not be easy. But I think we need to discuss this and on the upcoming meetings what to do in this area. Okay, so Mizo, thank you very much for interesting presentation.
Thank you.
Time. We hope to get back to you as well. I can also say we saw that Lantmäteriverket in Sweden had a survey sent out to ask everyone about this. In the international work that we have been talking about earlier on, where we are trying to do a gap analysis of in this area, that project is about to send out a questionnaire rather soon, and I hope that several of us can actually answer that questionnaire when it comes out. I will distribute to the whole group, and Mizo, I will be very grateful if you can help answering that, and also maybe talk with your customers if they need to answer some of the questions. That would be great, as well as Anton and several people more that are on this meeting. That would be appreciated. So we get back to this. Thanks, and I will change back to the PowerPoint presentation. And we also for this presentation we have a survey. I think the question is actually valid and works well also for this kind of presentation. Otherwise, just if not, just try to say something wise. But it's good to get the feedback. And Mizo, I will provide you with the results. We have decided that it's only the presenters that get the full feedback, actually, just to be sure. Everyone is free to tell and Håkan, if you are still here, I so much was leaving, so I will provide you with the same for your presentation.